I'm going to give you a quick overview and a quick review of what you need to kind of know by the time you finish chapters 1 through 3. One of the first things conceptually that you need to make sure you understand is the difference between ionic and molecular compounds. When we write sodium chloride, we're looking at ionic structures with crystal lattice, and simple compounds like CO2 or even this more complicated structure right here are covalent compounds or molecular compounds that have sharing of electrons. In order to write your chemical formulas, you need to have the skill of being able to look at that periodic table and know those oxidation states or charges that you're going to use in your ionic compounds. Your transition metals, of course, have a variety of charges, and you need to become familiar with those charges. You had to learn several of these last year, probably not gold, but tin, lead, probably not mercury, and you need to add these to your list. You need to recognize those transition metal ions. The other things you need to know, of course, are your polyatomic ions. You need to know them without having to look them up. You need to have memorized all your common polyatomic ions and kind of have an idea somewhere in the back of your head that they are bonded covalently within the polyatomic ion, and then those electrons are transferred from a metal ion, and then the metal and polyatomic ion are held together with ionic bonding. When you're thinking about chemistry, you need to think of it on the macroscopic scale, where you're things that you can see take place, boiling chemical changes. But you need to relate this to the submicroscopic and particulate level and the atomic and molecular level. Once you can understand how things are bonded, then you can understand how they interact, how they will go through chemical changes as well as physical changes. You can see this is clearly a picture of a chemical change. You can see that you've got heat and light given off, but is it true that if you have a chemical change, you also have a physical change? That's something I want you to think about as we progress through these chapters. Some of the other mundane things you need to memorize are all of your fundamental SI units, kilogram, meter, second, Kelvin, mole. Again, ampere and candela are really not used much. Ampere will be used when we do electrochemistry, but candela, never. But you need to know these. You also need to make sure you're familiar with your basic prefixes, certainly mega through nano. Occasionally pico will come in, and maybe some of these at some point when we talk about nuclear, but right now you need to know these and their exponential values. The other thing as we move through these chapters, you have to focus on sources of error, especially when you are in lab. What was the cause of your error, and how could you improve on that? When you're talking about error, you're also talking, of course, about significant figures and why they are important. Not just knowing the rules, but knowing why they are important and what information you get from them. Once you are familiar with all of your lab procedures, then you'll use your percent error as a way to figure out how good you were in lab. It's a comparison of your experimental value with a known value. And of course, I'm sure you remember the formula. Some of the experiments that the AP test will test you on, as far as historical experiments, would be Dalton's atomic theory, J.J. Thomson's discovery of the electrode with his cathode ray tube. So again, you want to know that experiment upside down and backwards. So when we discuss and review very, very briefly, we'll discuss Thomson's experiment and Millikan. This is not an experiment we discussed last year, so we'll go into a little more depth. One of the most important experiments, of course, was the gold foil experiment with Rutherford, and again, this is one we will discuss and review in a little more depth. Some other basic skills: make sure you can read an isotope symbol, that you know this is the mass number, this is the atomic number, this is the symbol of the element. Make sure you can get the number of protons and electrons and neutrons when you look at a symbol. And of course that you know that all elements have some isotopic forms. The average atomic mass is calculated from isotopic values and their percents. We'll work through some calculations and we'll talk about how the mass spectrophotometer gives us this information. Percent composition seems a seemingly simple and easy calculation, really can be far more in-depth and far more convoluted than you might expect, but understanding that compounds exist in percent ratios and how to use that is extremely important. You will move from percent composition into empirical and molecular formulas, calculations that you learned last year, and for some of you it was not your finest moment, so you really do need to review these types of calculations. Hydrate formulas. Again, you will be doing a lab where you create a hydrated compound in the lab and then you analyze it. And one of the ways to analyze a hydrate is by heating it to remove the waters, and you then analyze the amount of water, and that allows you to determine its formula. Once you're into determining formulas, you then are into determining chemical equations and reactions. This is a huge part of the chemistry that you will study, of course, so knowing reactants and products comes in more depth later on, but you need a basic understanding. And of course that starts with being able to balance equations. And then of course being able to do some good basic stoichiometry. That's the quantitative study. Without that quantitative study, chemistry would not be nearly as useful as it is. When you have your quantitative study, you then have your fancier problems, which are your limiting reactant. Find which one makes the least amount of product, and that would be your limiting reactant. Once you know your limiting reactant, it controls all of your other products that are formed. And then we'll move into a little more with the excess reactant this year. You'll need to be able to tell me exactly how much you have left when the reaction is complete. Percent yield. Once you've done your experiment, your actual over your theoretical, this tells you how good a job you did in lab. Hopefully you'll have some pretty good percent yields. One of the more difficult types of problems, and one that you have not had any experience with last year, will be your combustion analysis. And this is all based on some stoichiometry, some percent yield, some empirical and molecular formula. And again, these are not that difficult once you understand the basis of those problems. We will practice quite a few of them. The basic concept is that some kind of fuel is burned, the substance products go through, the water is absorbed, and the CO2 is absorbed, and of course all of the hydrogen came from this part of the compound and all of the carbon came from, there, so you'll be able to back analyze, turning the hydrogen and the carbon into the empirical formula. The last type of new problem that you will have is gravimetric analysis. Gravimetric, again, I'll spell this out, analysis, which is basically creating a known compound and then analyzing for a component that is in that compound. Here's a typical plan for that. You would take your sample that would contain the ion that you were interested in. You would then dissolve it, get those ions that you're interested in solution, then precipitate them, making a known compound. Once the compound is dry, you will weigh it, and now you have grams of this compound. And you will use the formula to back analyze for the ion that you are interested in. So this is just a quick review of everything we're going to cover in the first 3 chapters, and you need to get those chapters down really, really well before you move on.